Have you ever found yourself scrolling through your Twitter feed, just finding super depressing and negative tweets? Well, I certainly have. And when I see such, depressing feeds, it just really throws off the vibe for me. And you know what? I get it. This is a super first world problem. But if only there existed a way for us to find more positive Twitter accounts. And that's exactly what I decided to do. I decided to make a Twitter sentiment analysis app called PosiTweet. Bonus, at the end, I'll actually be showing you some of the more interesting results through the app. Now, before I begin, I just want to give a quick disclaimer. This video requires you to have some basic knowledge about neural networks, and in specific, recurrent neural networks, and as well as LSTM networks. You might be thinking, whoa, this is some next level stuff. Well, guess what? It's actually not that hard. And as a bonus, I actually made an article on all of these things, which I'll link down below. Now, you may be wondering, what the heck is this sentiment analysis? Well, it's exactly how it sounds. It's basically giving the computer a bunch of text and actually deciding, and actually the computer will tell you whether it has a positive sentiment, or something like, hey, this is great, or something that's a neutral sentiment, it's like, okay, or something that's sad, like, hey, you suck. And then there's actually many ways of doing this, and it's actually used quite a bit. So you can actually see how companies like Amazon would actually use this to actually track product reviews and actually see the overall sentiment regarding a product. Now, this can be done in a variety of ways, as I mentioned. One of the most prominent of which is using recurrent neural networks. And using this actually follows a standard deep learning pipeline. And then today we'll actually be looking at what this pipeline looks like from start to finish and how I actually made the app. Now, the first part is you have to actually clean and process the data. So you can't actually just give the computer just a bunch of sentences. You actually need to put them in mini batches. And even once you put them in mini batches, you have to do a number of processing steps. One of the most popular of which is tokenization. Tokenization basically means taking basically all the vocabulary within all of the text that you've given the computer and converting them to numbers. Now, computer doesn't actually like working with numbers. It actually talks in something called binary, which is just zeros and ones, and it really just prefers plain old numbers. So we basically give the computer numbers, and then once we've given this, it's actually able to use the data, and then with that data, you actually have to give it labels. Labels actually means like, hey, like this piece of data was actually positive. So for in my case, I'm using a label of 0 or 1, which is 0 being negative, 1 being positive. You can also add a label for neutral, but unfortunately for my dataset, I was not able to find any neutral tweets. Now we can move on to step number 2, which is actually training the model. So we as humans actually don't have to do much to actually train the models. All we have to do is specify a network architecture. So this is basically telling what type of layers do we want. Do we want LSTM layers, RNN layers, or just plain old fully connected layers, right? So we actually need to define the exact architecture of the network beforehand. And then from this, the computer can basically form a blank network, and then it can actually start processing the data and actually start learning about trends and actually giving some insight. In this process, you also have to choose parameters. So these parameters would be like the input size for each single layer, and then the output size for each layer. And then this will also include the number of hidden layers. So in a neural network, there would be an input layer, hidden layers, and then the output layer. You can actually read more down below. Now, a quick side note, for the sentiment analysis model, I've actually decided to go with LSTM layers rather than RNN layers because they're actually much more efficient at storing long-term memory, which is actually quite important when you're dealing with large tweets. So you may have heard all me just saying that, we actually don't have to do much, but you might be wondering what the computer actually does, because this is actually the hard part for the computer. And what the computer is actually doing is just a whole bunch of math. So the computer is actually passing the output, just passing the data throughout the network using a process called feed forward. So it basically feeds the data from one layer to the next, and then it actually tries to guess the sentiment in our case, which would be positive or negative. And then let's say the computer gets it wrong. So now what does it do? It basically sends a result all the way back through each single layer through a process called back propagation. And this is actually the basics of how it works. It basically sends data forward, gets a prediction, and then basically updates a network through a process of back propagation. And this is also using partial derivatives and things like that. So it's more complex math. And if you want to check it out, I'll definitely link a research paper to it down below. When the computer keeps doing this process millions of times, it actually gets to a point where the computer can predict our data sentiment with about 95% accuracy, and that's crazy. We can move on to the third and last step in training our model, which is actually testing and validating our data. So as you can imagine, the computer is probably really good at actually predicting the sentiment within the text it was actually provided. But what about other tweets and other text? Well, this is where testing actually comes in. So you basically give the neural network a whole new set of data, and then from there it's basically able to predict, and then all we're really doing is just looking at how accurate the model is. So validation is very similar to testing, except in validation you're also able to save various checkpoints within the model to actually get the highest amount of accuracy. Now, you may be wondering, how does this new data just come about? Well, it really doesn't. In the start, which is data processing, we actually split up the data into three components, which is the testing, training data, and then it's a testing and validation data. So training data is actually majority of the data set, and it's usually around 60 to 80%. And this is the data which the computer actually trains on. Now the testing and validation data are actually split up from the remaining 20 to 40%. And then this is actually used to actually test whether the neural network is actually going good, or does it actually need to get more learning going. And the very last step that I kind of forgot to mention is sit back and relax, because we are done. So now you may be wondering, that wasn't so hard after all. And in reality, well, it really isn't, because with the rise of these super simple to use libraries, especially in languages like Python, like PyTorch and TensorFlow, the computer is really doing all the hard work. And that's really good for lazy people like me. So now we can actually move on to seeing some interesting results from our classifier. Now that you've seen some really cool things that we can do with neural networks, and specifically RNNs and LSTMs, you may be wondering what else it can do. And one of the other really cool things it can do is actually can generate a piece of text. So let's say an essay, and it can actually do that from just like one sentence. And that is super cool. And I've actually done a model which is training the computer to speak in Shakespearean. So definitely check out my GitHub for this project and also for that project. Cheers.